right, today we're going to talk about the toolkit for this unit. This is the Unit 6 toolkit that is shared with you. So if you want to print this or just take notes on the side, if you don't have a printer capabilities, that's fine as well. It shouldn't matter either way, just so that you get some notes. So today in Wednesday's lesson, you were talking about tangent lines. So the discussion is about what are these? Tangent lines are lines that do not touch a circle in any way more than one time. So notes off to the side that I would make, there's basically two examples of this. Oh, it's not a very good circle. Let's try again. So would be a circle like this, and the tangent line comes off the top. You can use this to actually make right triangles. So what we know is we have a triangle that looks like this, where this is your tangent. The radius is this number in here, or this segment in here, and it forms a right angle. This is the center of your circle. So for these, if I put an A here, a B here, and a C here, these you can use A squared plus B squared equals C squared. You can also use SOHCAHTOA here as well. So that's one of the relationships. So when I look at these diagrams that you're working at, this one or that concept is actually used to do this one and this one here. Okay, then the other concept that comes out of the tangents is that when two tangents go to the same circle, such as these two, and what we know is A, those are right angles, and B, this segment and this segment, the two tangents from the same point actually happen to have the same length. And so it's beneficial sometimes to draw in the segment because now you actually have Pythagorean theorem again, you have right triangles, all those things apply. And so for these, we'll change the color here, number 9 and number 5 both relate to that concept there and being able to set those up. And both of these will be on your quiz tomorrow. So those are your two tangent concepts that are going to be used throughout. Okay, if you go to Learning Target 2, this one is about chords, which was part of your discussion, I believe, on Monday when we talked about that. A chord, if we talk about its definition, is a segment that has endpoints on the circle. Okay, that's the little symbol for circle, the little O with the dot in the center, and you'll see us kind of use that quite a bit. So on this one, it says that it's perpendicular, so that means that's a right angle. What we know when we have a chord that goes to this, that has a segment to the center perpendicular, is that it divides the chord into equal parts. So on this one, you would have your 10 squared equal to 8 squared plus BM squared. And you'd solve and work that out. So 100 minus 64 equals 36. And when you square root that, you get 6. But don't forget, that's just half of that. So the whole length of AB actually equals 12. This one now wants you to find the measure of the angle. And we're going to assume that we are still using the same numbers for this particular one, but we want to find angle BOM. So this is where your SOHCAHTOA comes into play. So to decide which SOHCAHTOA you're using, you've got to label these. So we always start by labeling the hypotenuse, which is our 10, and the 8 then is the adjacent side. So what uses an A and an H at the same time is the CAH. So we're going to do cosine of angle O equals adjacent over hypotenuse. And when you're doing finding the measures of the angles, you have to go into the inverse key to do that. Make sure you are in degree mode. That's kind of a key piece that you need to make sure those calculators are set to degree mode. Many of them are set to radians unless you do that. So 36.9 degrees is what you should get. Test that. Make sure that you actually do get that. If you need to pause the video for a moment to do that, please do so. Okay, but that's how you use SOHCAHTOA to find angles. as you work through. Key is to recall and remember that a chord, when it's perpendicular, goes through the center and it divides the chord into two equal parts. So those are kind of the big ideas on chords. All right, next was central angles and its intercepted arcs. And central angles was introduced on Monday. And so for this one, what we know is the measure of the central angle and the intercepted arc are equal to each other. With this one, kind of how I describe this to students is if I'm starting here at the center of the circle and I spin all the way around, how many degrees does it take to go around the center of the circle? 360. If you start out here and you go all the way around the outside and end up back here, you also go 360 degrees. So each of these angles here in the center is the same as each of those angles on that outside. So this distance and this distance have to be equal. That's really a key piece to that. All right, then they introduce arcs to you. Okay, and there's basically two types of arcs. There's a minor arc, and minor arcs will require, or you can use two letters. So if I want to talk about arc WV in this particular diagram, I'm talking about that shortest distance in here. And all of these arcs are less than 180 degrees. Okay, they're all less than 180. So if the measure of your arc is more than that, then it's clearly not a minor arc because those angles have to be less than 180. Yeah, the other type of arc I'm going to put over here on this side is what is called a major arc. And major arcs require three letters. So if I want to talk about the arc that goes from B and goes all the way around to D, I need to use three letters. B and D being the beginning and ending point. If all you see are those two letters, you're really talking about the short distance here. We're not talking about the short distance, we're talking about the major arc. So I need to pick either the F or the E, and it doesn't matter which one I put. Basically, it's telling you the direction. Notice the arc that I put above the particular angle here, or above the three letters, is kind of curved, and that's how we represent arcs. So when possible, make sure you do that, okay, to show that. So other things in this diagram to kind of point out or to pick up on is the marks right here in the center. Those two arcs are telling you that this angle and this angle are equal. So we haven't seen those for a while, but they do mean that those are equal angles as you're setting those up. We also want to look for diameters. Diameters divide circles into two equal parts. So this part is the same as this. So if it's 360 to go all the way around, then each of those is going to have a measure of 180 degrees. And that's helpful to us. If this is 126, we can cut it in half, or not cut it in half, but subtract it from 180 to get that part there. And 180 minus 126 is going to give me 54 degrees. Okay, in this one, vertical angles becomes a key part to this. So that angle to that angle is the same, making this one also 54. And that means this one in here is 126, the two of them. Cut in half makes each of those angles 63. And then you can add things up. You're going to go from E to F. And what we know based on what we see here is that it wants you to go the long way around. Notice the letter here. Actually, we're going E to C. So E is here and C is here. Since there's three letters, we got to go from E to F and then around. So you're going to add up those arcs that make up that angle. This one, because it only has two letters, wants you to tell the shortest distance from V to W. So it's actually this one in here. And again, we have a diameter here. So I know that this distance is a total of 180. And so I can set up an equation in here to find some things on that one. I also know, and probably more importantly, on the other side, well, actually this one, we're going to have to use some vertical angles. Let me clear some stuff off of this one here. The vertical angle is this one to this one. And so these are equal. So this is 5x plus 10. And so we know that 5x plus 10 plus 5x plus 10 should equal 12x minus 2, and find your x that way. So this one's got a little more work involved. But I wanted to point out here, importantly, the difference between a major arc and a minor arc. I noticed in some of the assignments, and I think it's due to kind of writing things, some of you maybe are using lowercase letters like this when you're labeling arcs. Make sure that you're always doing the capital letters. You're using points, and it's a little geometric kind of thing, but those points are always given by capital letters. So just a little notation with that. All right, Tuesday's lesson was a focus on inscribed angles. And these are angles that are inside of your circles. The last time we used inscribed was when we were talking about triangles and inscribing a circle in it. This is the other way around. You're inscribing an angle in it. So the measure of the inscribed angle is half the measure of its intercepted arc. So on this diagram, if I draw this segment over, I have created on the inside a triangle. And what you know about the angles of a triangle, they equal 180 degrees. But if I want to look at the arcs that go all the way around the outside, and I go from M all the way around back to M, a full circle has to be 360. So that's another way to help us know that these two things can't be the same. They're not related in that way. They're half. So if this angle out or arc out here is 78, the angle inside is half of that, which makes it 39 degrees. Okay, you're going to have, we're going to have some quadrilaterals. We'll do the middle one here. Some of these you didn't have as much focus on, but we're going to focus a little bit on what we can learn about those. So that's the angle. If I stand in the corner of 137 and I put my arm out to B and my arm out to D, what's in between those from here to here is its intercepted arc. That's the angle that's going to be doubled. So 134 doubled makes that 200, makes the distance from here to here 268 degrees. That's our arc. That's what the distance from B to D is. Now again, go back to minor major. That's a major arc. So we want to use the three letters B, A, D, and that tells me that angle is more than 180. So now, how do I find angle X? Well, extend your arms out to angle X, and you're going to go to D, and you're going to go to B. So this distance is what I need to know to get to X. Well, if I start at D, go all the way around, I'm at 360. 360 minus 268 tells me what the arc in pink is, and that's 92 degrees. And so half of 92 is going to then give me X. So half of 92 is 46 degrees. So what we know about opposite angles here in your quadrilaterals, when a quadrilateral has every vertex on it or inscribed in the circle, is these opposite angles are going to add to 180, because each arc, when you extend the angle out and find its intercepted arc, the two of them make up the whole circle of 360. So the pair of those have to add to 180. And you'll see that concept come up a little bit as you work. All right, to find the 24, over here we have that to find the X. One of the things you want to look at here, you're looking for diameters. And if they put a line with a dot on it, that's a diameter. If it doesn't have it, or they don't say, you can't assume that. This one isn't as difficult as it looks to begin with. We have the 24 angle in here. And again, that's an inscribed angle. So if you extend your arms out, you're going to come out here to LJ, and that is double. So that's 48. So on this one, to get to the X, you have to add the 48 and the 248 together, which is going to give you 296, and then take 360 and subtract the 296 away, and you're going to end up with 64 degrees for that one. And that's what the arc is. If you wanted to find the angle in here, you'd have to go to half of that, making it 32. And that's how your inscribed angles will actually work. We're going to talk more about the other stuff on this another day, but these are the first 4 concepts that are actually going to be on that quiz that you're going to be preparing for tomorrow. If you want more information, just let me know. But for now, that's where we're going to be.